Hi students, problem number 7. When a light of frequency 9 into 10 power 14 Hertz is incident on a metal surface, photoelectrons are emitted with a maximum speed of 8 into 10 power 5 meter per second. Determine the threshold frequency of the surface. So first I have grouped the given information. So this symbol nu represents the incident frequency. Okay, the incident frequency nu equal to 9 into 10 power 14 Hertz. Now the maximum velocity of the photoelectron is V max, that is equal to 8 into 10 power 5 meter per second. Now the mass of the electron, though it is not given, we are supposed to remember. So I have written mass of the electron is 9.1 into 10 power minus 31 kilogram. Now what is asked here is the threshold frequency, the minimum frequency required for photoelectric emission to take place. That is denoted by the symbol nu naught. So now from Albert Einstein's photoelectric equation, okay, from Einstein's photoelectric equation. So the incident energy is h nu, that is equal to h nu naught, that is the work function, plus half m into v square maximum, that is the kinetic energy maximum. So this is the root equation we have to remember to solve all problems in photoelectric effect. So now I will take this h nu minus of h nu naught. So this h nu naught, that is the work function, is taken to the left side. So minus h nu naught. So this is equal to mv square, m into v square maximum divided by 2. Now nu is given and the nu naught has to be determined, is it not? So I can also shift the other way. H nu naught is equal to h nu minus mv square by 2. So h nu naught is now equal to h nu minus mv square maximum by 2. Now I need only nu naught, so I can divide all the terms by Planck's constant. I will write again, nu naught is now equal to, so I have divided left side by Planck's constant, right side also I have to divide by h. So the first term will become nu minus m into v square maximum divided by 2h. So this is the final step in which we have to substitute the given quantities. So now nu naught, okay, therefore nu naught is now equal to, first term is what, the incident frequency 9 into 10 power 14. So I will keep it inside a bracket, 9 into 10 to the power of 14 Hertz minus of, now inside this bracket, mass of the electron is 9.1, okay, 9.1 into 10 power minus 31 into, now V maximum is given here, 8 into 10 power 5. Here I have to substitute the square of that, is it not? So directly I am going to substitute the square. So 8 square into 10 power 5 whole square. So this is 8 square, okay, 8 square into 10 power 5 square is what? 10 power 10 divided by, so this has to be divided by 2 multiplied by Planck's constant is 6.625 into 10 to the power of minus 34. So this is first term is as it is retained, 9 into 10 power 14 minus 9.1 into, now 8 square is 8 8s are 64 divided by 2 is there, okay, 64. So 8 square totally, if I will cancel by 2, 64 by 2 is how much? 32. So this number 32 I will write into, okay. Now this is 10 to the power of minus 31 into plus 10. So this is 10 power minus 21 whole divided by 6.625 into 10 power minus 34. So this is now equal to 9 into 10 to the power of 14 minus So here we have to find 9.1 into 32. Okay. So the product is 9.1 into 32. So this is 291.2 divided by 6.625 into. Now this is a 10 power minus 34 is coming up as plus 34. So 34 minus 21 will become what? A 10 power 13. Okay, this will come as 10 power 13. So this is equal to 9 into 10 to the power of 14 minus a second term. I have to find out 291.2 divided by Planck's constant 6.625. So this is equal to 43.9. 43.9 into 10 to the power of 13. Now here 10 power 14 we have. So here also I want to make it as 10 power 14. So this is equal to 9 into 10 power 14 minus. So this can be written as 4.39 into 10 to the power of 14. So that we can take the common factor as 10 power 14. So nu naught, now nu naught is equal to 10 power 14 into this 9 minus 4.39. Okay, 9 minus 4.4 I will write. 4.39 can be rounded off as what? Nearly equal to 4.4, is it not? So that this is 9 minus 4.4. So this must be equal to what? 10 power 14 into 9 minus 4.4 must be what? 4.6. Therefore, the threshold frequency must be equal to 4.6 into 10 power 14 hertz. So this must be the answer. So what is given here is the incident frequency is given and the threshold frequency has to be determined. As I told you, most of the numerical problems in photoelectric effect, you will have to remember now Einstein's photoelectric equation. So we started with Einstein's photoelectric equation, and from that we have got an expression for the threshold frequency nu naught. Okay, and the answer is what? Nu naught is equal to 4.6 into 10 power 14 hertz. So this is the right answer. I hope you must have understood well. Fine.